We have a water wheel center O, radius 10 meters. Let's mark that on so remember what that is. 10 meters is that distance there. Water flows into buckets, turning it clockwise so the wheel goes this way. The height h meters at the top of a bucket, so a bucket here, the top of it, is modeled by this function, so the height here is a function of t in time. T seconds after it passes through point A, so it's starting here, so it should start here and go lower, 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 go down to as low as the lowest point, back up to the highest point and back down again. If that's 10 meters, this point here should be 20 meters above here, so that should be 20 meters across there. Find the height of point A above the ground. Well, given they give us exactly that function, let's put it into the calculator and see what it says. So to do part A, I need a sketch of my graph, so I'll see what I've done now. Let's add another graph page to get the water wheel on there. Add a page, graphs. Put in the graph 13 plus 8 cosine of, in brackets, fraction pi over 18 times t, which we have to put an x in because we've got x on this. In fact, I can even copy that to Control C. We'll copy that out for the next bit because I need that same bit. Then subtract 6 sine and Control V to paste in the same bit we had before. Makes it easy to type in. That's my graph. And I can't see it. Well, the water wheel's 20 meters high. Let's go up to 25 meters to see what we can see. Well, there's my graph. I'm in degrees. I need to be in radians. That's it in radians. It can't go below 0. Well, let's have -1 so we can just see the axis there. The 25 is okay. Let's take this up to 60 seconds to get 1 minute what's happening. So we can now see 1 minute. I don't just see the negative sign, that -1. And then we need to find the point A above the ground, so this point here. Well, the easiest way to find things, menu, geometry, points and lines. If I do point on, it will give me points actually on the curve. And to get points on the curve, I can just click twice to put a point on the curve anywhere I like. I can add as many points as I want. I'll put a few on there, we'll see how many we need, and escape just to get this out of it, adding the points. So now we want when x is 0, so change that x value to 0. Oh, it starts at 21 meters high. And here we need to put in, this is y equals, and the graph is, actually I could put all this to show what the graph is, but actually I could just use h of t equals h of t, where this is t and this is y, and we know this is 0, 21. So therefore A wants to find A is 21 meters above the ground. Part B, part AI, sorry, that's AI. This is now AII. Calculate the number of seconds it takes for the water wheel to complete one rotation. So I could calculate it from this because I can see here what's actually making it go round. And pi divided by the period is actually the period that I should be getting to do. So it should be 2 pi divided by the period. It should give me this, so it's 2 pi over 36, means it's 36 seconds to do one rotation. Or I can check it on the calculator and see how far it is between two distant points. So now I can try any values on my calculator and see what it is. So I can look here and say this is and on to complete one rotation. Well, actually, if I want to do that, that's 21 meters. Let's set this one. Actually, I'll control click on this and drag the point over to here so it's roughly where I want it, and change that to 21 meters. Oh, it takes 36 seconds to do a full rotation. So we should be able to calculate how many rotations it makes in an hour. 36.21, if I find that point. So 36 subtract 0 equals 36 seconds for one rotation. Hence, find the number of rotations the water wheel makes in 1 hour. So it's doing it 36 hours, so I need 60 times 60 is the number of seconds in an hour, divided by 36, which gives me 100 rotations per hour. Part B, a bucket moves from around to point B, so it's gone from A to B, a height of 4.6 meters above the ground. It takes K seconds for the top of this bucket to go from A to B. Find K. So look on the graph, and we need to find where this point is here, which is at, I need it to be 4.06 meters above the ground. So on the graph, I can change, I've put in 4.06 as my height, change this to 4.06 meters, and actually it takes 11.651 seconds. I can see more if I want to by doing plus on that. 6510373. So that's how many seconds it takes to get from point A to point B. That's point B. So that's our value of K. And finally, it gets me to 21.651 meters. So that's 21.651, 4.06. So BI K equals 21.651 ... approximately equal to 21.7 to 3 significant figures. That's just B. The chord AB is 17 meters. So I want the chord from here to here. And we know this is 10 meters. This is 17 meters. Correct 3 significant figures. Find 17.0. Find the angle AOB. So we want to find this angle. Well, that's a nice little triangle. And if we call this angle C, A and B, that's little b, that's little a, and this is little c. So we can do a cosine rule on that. C, and we don't need part I for B, it's just part B. So now we have that cosine C, or I should replace that with a cosine AOB, isn't it? AOB is what it officially is, and that should be a squared plus b squared subtract c squared over 2ab, which is, put the values in there. So we should have a squared is 10 squared plus 10 squared subtract 17 squared over 2 times 10 times 10. And do an arc cosine on that. So we get that AOB is equal to, make sure that we're in radians because the question's in radians, 2.031970 ... which is approximately equal to 2.03 radians.